help me understand the function of the node dual clip loader.
Sure, the dual CLIP loader node loads two CLIP models. This allows you to use two different CLIP models to generate text embeddings, which can be used for various tasks, such as image generation or text analysis. Would you like to explore the functions of other nodes in the image?
Okay, speak to me in very simple language.
Okay, I can definitely speak in simpler terms. The dual CLIP loader basically brings in two models that understand language to help with image editing. Is that simple enough?
It helps AI to understand text.
Yes, that is correct. The CLIP models help the AI understand text prompts by converting them. Indeed, and then that text understanding is used to guide the image editing process. Do you want to know what any other nodes do?
You said by converting the text into what?
By converting the text into numerical representations called embeddings. These embeddings are a way for the computer to understand the meaning of the text.
Oh, I see. You mean convert the text into numerical representation, and these numerical representations, you called it embedding.
Yes, you are absolutely correct. The numerical representations are also known as embeddings.
Okay, then it connects flux guidance.
Okay, the flux guidance node adjusts how much the text embeddings influence the image generation. It helps fine-tune the results. Would you like to explore more nodes?
Explain it in simple way.
You mean... Okay, in simple terms, the flux guidance node is like a volume knob for the text influence, allowing you to turn up or down how much the text affects the final image. Is that a bit clearer?
So the higher the value, the stronger the adherence.
Exactly. A higher guidance value means the generated image will stick more closely to what the text prompt is asking for.
And then how about in-paint model conditioning? It has so many inputs. What is VAE?
Okay, the VAE stands for Variational Autoencoder. It's a type of neural network that compresses the image into a smaller representation and can then reconstruct it, which is helpful for image processing. Would you like me to clarify any of that?
I'll put it in a very simple way or simple term. Use analogies if necessary.
Okay, in very simple terms, the VAE is like a really good photo compressor. It shrinks the image data so it's easier to handle, and then can also expand it back to full size when needed. Does this analogy work for you?
Okay, yes. But how about latent? What is the relationship between them?
Okay, the latent refers to the compressed representation of the image created by the VAE. It's the smaller, more manageable version that the K-sampler node uses to generate the final image. So the VAE encodes and the K-sampler decodes using the latent. Does that connection make sense?
So the latent refers to the compressed image.
Yes, that is correct. The latent space is a compressed representation of the image.
Why do we need this hidden space?
The hidden or latent space is useful because it makes complex image data easier for the AI to manipulate. It's like having a simplified blueprint of an image, allowing for quicker edits and creations. Does that help?
So it is not just compression, but keep the main elements of the image.
Precisely. The latent space not only compresses the image, but it also aims to retain the key features needed for accurate reconstruction and manipulation.
Why do we need these two nodes, in-paint model conditioning and K-sampler? Why do we need them?
Okay, the in-paint model conditioning node is what takes the text and image info and prepares it for the diffusion process.
And then everything
Okay,
goes
the in-paint
to...
model, then everything goes to the K-sampler. Is that what you wanted to confirm?
So the in-paint model conditioning is like the preparation phase.
Yes, the in-paint model conditioning node does prepare the data by combining the text and image inputs before the final generation step.
Everything happens in case sampler.
Exactly. The K-sampler node is where the actual image generation or in-painting happens, using all the prepared data. Is there anything else you'd like to know?
And then there comes VAE decode. It's like decompressing, right?
Yes, that's right.